Hello student, my name is Rajneesh Kumar. I am the assistant professor of mechanical engineering department from Rama University. Today I am here to give you a brief introduction of a chapter in fluid mechanics which is called kinematics of flow. In kinematics of flow, first we have to go through with what is flow. What is flow and then what is kinematics. First we have to study about flow. What is flow? That means the motion of a particle under different types of forces. The motion of a particle under different types of forces. These forces may be you can understand by your name, that is called pressure forces, inertia forces, viscous forces, elastic forces, etc. Now we have to move forward to kinematics. In kinematics we already know that we studied about the motion, but before we go kinematics, first we have to go through with in physics, that is called the study of statics and study of dynamics. In study of statics, we already know by the name of stat, that means the rest. Here the fluid particles are totally in the condition of rest position, that is study is called statics. Now we move towards dynamics. Dynamics is represented as the study of particle of motion in motion. Therefore, we can understand the difference between statics and dynamics. In statics, the motion of fluid particle is in rest condition, and in dynamics, study of particle is in the condition of motion. Now, this dynamics is further converted into two parts, which is called kinetics and kinematics. In kinetics, we studied the motion of particle under subjected different kind of forces. In kinematics, the motion of fluid particles is only considered, but here the force are not considered. Here we totally studied about the fluid motion, but we cannot consider the types of forces which is subjected on this motion. Therefore, we already give you a brief about kinematics of flow. Now, this study of flow is gone through under these two various famous approach, which is called Lagrangian approach and Eulerian approach. In Lagrangian approach, we trace the each and every fluid particles which constitute the fluid motion, Therefore, in Lagrangian approach, the position of a fluid particle becomes the function of its own identity and time. Therefore, mathematically we can written as S is the function of S naught, that is particular its identity and time. And now we are going through Eulerian approach. In Eulerian approach, the study of fluid motion is constituted overall particles, where we can also say that the properties of fluid motion can be the function of its space coordinates and time. For example, I can write the velocity of a fluid particle is the function of space coordinate, that means x, y, z, and time, that is t. Now, we go to study about types of forces. The types of forces, the types of forces, as I earlier told you about these types of forces in Lagrangian approach, where pressure forces, viscous forces, elastic forces and inertia forces. Now we have to understand the types of flow. In types of flow, the first category is known as steady and unsteady flow. In steady and unsteady flow, first start with steady flow. In steady flow, the fluid properties, for example, velocity, pressure and density, are constant with respect to time. Therefore, we can represent these properties in mathematically form like P V rho with respect to time as 0. We can understand why we written these fluid properties as 0, because these fluid properties are constant in terms of time. When we differentiate these fluid properties with respect to time, it becomes 0, whereas in unsteady flow these fluid properties are not constant with respect to time. Therefore, it will become written as not equal to 0. Now we move further different types of flow. The second one is uniform and non-uniform flow. In uniform flow, the fluid particles are moved along parallel to each other. If we can draw the fluid field, so we can say that these fluid layers are parallel to each other. This type of flow is called uniform flow. And non-uniform flow, in which fluid particles are moving in zigzag way. That means fluid particles are not parallel to each other. Now we move further, third category, which is called compressible and incompressible flow. If we look out this category, we can say that the fluid having constant density in a fluid field, then the flow is called incompressible flow. If the fluid having variable density, then the flow is called incompressible flow. Now we come towards the next category of type of flow, that is called rotational and irrotational flow. In rotational flow, the fluid particles are moving along streamlines. Streamlines are imaginary lines in a fluid field on which if we draw a tangent, that gives the velocity of that particle. And these particles are also rotated about their own axis. Therefore, this type of flow is called rotational flow, where in irrotational flow the fluid particles are only moving in a streamline and fluid particles does not rotate about their own axis. Now, the last category of type of flow is one dimensional, two dimensional and three dimensional flow. Here we can easily understand by the name of particular flow, that is 1, 2 and 3 dimensional flow. In one dimensional flow, the flow occurs only in one direction, that is maybe x, y and z. In two dimensional flow, the flow occurs in plane. We can say that a plane which is constituted with the help of two coordinates like x and y, y and z and z and x. That means the flow occurs in two directions, that is called two dimensional flow, and in three dimensional flow the flow is exists in a space, or we can say that the flow is exists in a fluid field where the all particles are moving in random directions, and simply we can say that the flow occur in x, y and z directions. Now, the last important topic of this chapter is continuity equation. Next topic in kinematics of flow is continuity equation. Before we go through this continuity equation, first we talk about discharge. The discharge is the amount of water which is passing through a section per second is called discharge. Like this is the construction of a pipe where the section 1 and section 2 represents the two cross sections of this pipe. That means the amount of water that is denoted as meter cube, that is also the volume of fluid is passing through this section per second, that means the discharge. Now, this discharge is also denoted as meter cube per second. Now, this meter cube per second is written as meter square into meter upon second. The meter square is nothing but, you already know that it will be written as area, and meter per second will be written as velocity. Now, this discharge is also written as area into velocity. With the help of this discharge equation, we can easily write down the equation of continuity equation. Now, the continuity equation for pipe flow is written as A1 V1 is equal to A2 V2, and this continuity equation represents for incompressible flow. Now, what is the continuity equation for compressible flow? That will be written as rho 1 A1 V1 is equal to rho 2 A2 V2. This equation is for compressible flow, where we already know that the compressible flow is that type of flow which have variable densities. Now, we can say that rho 1 represents the density of fluid at cross section 1, and rho 2 will represent the density of fluid at cross section 2. Hence, it will a good day for you.